Greetings and welcome to our lecture. This lecture focuses on matrix, and in the class here it is Maths 110. So matrix is a new topic for Maths 110. So matrix is used in various fields, and when we talk of matrix, in short we are talking of a rectangular array of real numbers arranged in m rows and n columns. So matrix, they are used in various fields such as solving systems of complicated linear equations, linear maps, etc., even robots and debating, because all those fields require matrix. Now, when we talk of matrix, there are certain concepts that you should know. It's very important. So as I said, we are looking at matrices. So matrices, and with this, we are with class M110. So this is for M110 only. Okay, so one thing you should know with matrix is that you should be able to know the dimension of a matrix. It's very important. So by dimension of a matrix, we are talking of how big a matrix is. So dimension is very important, and in this regard, dimension mostly it is written in the form of m times n. By m times n, our m here, we normally look at it from the angle of rows, and our m, we look at it in the angle of columns. So this is very important, and I thought you should know as we will be beginning. So how do we determine the size of a matrix? Let's look at an example. In this regard, we say example 1. So if example 1, let's say you have a matrix in the form of 2, 1, 6. We can also have 3, 7, 8, like that. So ideally, when you look at this, this is a 2 by 3 matrix. Why? We have, look at this, 1, 2. So all these are what we call the rows. So in short, when we talk of rows, we are talking of horizontal entries. And when we talk of columns, we are talking of vertical entries. In this regard, 2, 3, 1, 7, 6, 8, these are verticals, or they are standing at 90 degrees. So these are columns. So these, all these, they are what we call columns. Okay, so now when we look of a 2 by 3, in short, we are talking of the L shape. Okay, so the L shape, where we have R and we have C, and here you multiply. So in this regard, we have 1, 2, so this is 2. By column Z, we come here 1, 2, 3, so this is 3. So that's how we call, that's why we call it a 2 by 3 matrix. The other part that you should know, which is very important and cardinal for you, you should know the entries in a matrix. So a matrix entry is very important for you to know. So entries in a matrix, by entries in a matrix, we are locating each and every number which is in a matrix. So in this 2 by 3 matrix that we have 2, we have 3, we have 7, we have 1, we have 6, we have 8. These can be identified by a special simple formula which is called AIJ. This is a locator of each and every entry in our matrix. So in this regard, let's say we are interested in finding the number 7. You have seen where 7 is? So 7, in this regard, 7, it is in the position of matrix A, and it is in the second column and the second row. Okay, so second row, second column. So we start with row, then column. Sorry about that. So let's look at number 8. Okay, number 8, it is in the second column, you have seen 1, 2, then you start counting the going this side 1, 2, 3. So third row. So this is the entry. Let's try to see if you can locate for me number 3. Number 3. Number 3. Let's go. Number 3. Exactly. So the number 3, it is in the form of 2, 1. You have seen, eh? So you have 1, 2, and the first column. So second row, first column. Okay, so these are the entries I thought you should know. They are very, very, very important for you. The other part that you should know, excuse me, you should know also the definition of a diagonal. What is a diagonal? It's very important you know these diagonals. Diagonals. So what is a diagonal? So a diagonal, in this regard, it is in the form of a square matrix. Always diagonals, they are applicable when we talk of a square matrix. I'll talk about that later. So in this regard, a diagonal should be either in the form of this 2, 7, 3, and 4. Okay. So this entry 2 and 4, it is what we call a diagonal. So I can use my pen here, you have seen. So I've crossed this way. So this is my diagonal. So my diagonal here, it is a 2 times 4. It is my major diagonal. My minor diagonal starts at the far end and going to the far end here in that case. So my minor diagonal, this is, let's say this is my major diagonal, and the minor diagonal. Minor diagonal, it is 7 times 3 as my minor diagonal. I thought this you should know also. It is very, very important. So diagonals comes only in square matrix. So you will never be asked to find the diagonal in a matrix that is not a square matrix. That is very important. Maybe let's also look at the other aspect, as in what are the types of matrices that you should know. There are various types of matrices, and I'll bring some of the matrix that you should know, which is very cardinal for you. Let me remove this. Okay, so we have got various types of matrices, and I'll start with the matrix that are simple. Okay, so types of matrices. Okay, the first one is a column matrix. A column matrix. The other name for a column matrix is called a column vector. By a column matrix, we normally say this is a matrix that has just one column. That's all. One column. So I've told you about what columns and what rows are. So in this regard, you are talking of something that is in the form of, let's say you have this 1 and 2. You have seen that we have got 1, 2 rows, but 1 column. Remember, the columns, they are always vertical and the rows are horizontal. So I've got 1. This is a column matrix. You can also have it in the form of 1, 0, 7. This is also a column matrix. Why? There's only 1 column. That's all. But we have got 3 rows. This is very cardinal for you. Let's look at the second part also. We are looking at the row matrix. What is a row matrix? It's the opposite of this. This one, it only has 1 row. The other name for a row matrix is called a row vector. So in this regard here, we are talking of something that is in the form of, let's say 1, 2. Okay, 1, 2, it is a row matrix. You can also have something that is in the form of 2, 7, -8. like that. Okay, this is also a row matrix. Why? There's only one row but two columns in the first one. Here there's only one row. We have got one row but three columns. This is what we call a row matrix. The other part that you should know equally, you should know what is called a square matrix. A square matrix, this is when the rows and the columns, they are equal. So row and column should be equal. So this is what is called a square matrix. In this regard, we are talking of a 2 by 2, a 3 by 3, a 4 by 4, or even a 1 by 1. Yes, even a 1 by 1. So this is a square matrix. The other type of a matrix you should know, it's what we call a zero matrix. A zero matrix. What is a zero matrix? A zero matrix is a matrix that has all entries equals to 0. As simple as that. So all entries here are equals to 0. Example, you can have 0, 0, 0, 0. Like that. This is a zero matrix. You can equally have anything in form of 3 by 3, 2 by 3, but all entries here, remember, they are 0. Okay, so this does not mean that this is equal to 0. No, this is just a zero matrix. All right. So the other part that you should know, I thought you should know, it is a unity matrix. Okay, a unit matrix. Or before we go to a unit matrix, let's look also at a diagonal matrix. It's very, very important. Before that, I thought we look at this, I think. A diagonal matrix. What is a diagonal matrix? A diagonal matrix is simple. For a diagonal matrix here, we are talking of a matrix that has all entries equals to 0 except the diagonal, the main diagonal to be specific. Okay, so let's say you have something that is in the form of 1, 7, 0, 0. Okay, this is a diagonal matrix. You see the diagonal is defined. There is 1, 7. You can equally have something that is in the form of 1, 0, 0. You can have another 0 here. Then you can have 4. Let's say 4, 0. You can have a 2 here. You can have 0. You can have 0 there. You have seen? So the diagonal here, which is 1, 4, 2, is in that form. So you can get even a pen. You see that a pen here, it is in that form. So if I cross up here, you see that this is a diagonal. It is in that form. So equally even here, if I bring my pen here, I put my pen here, you see that I have the zeros. So the only entry here, it is just the diagonal. The rest, they are zeros. You have seen there are zeros. So this is what we call a diagonal matrix. I thought this is very, very cardinal, and you should know this, that a diagonal matrix really, it is a matrix that has entries zeros except for the main diagonal, which has an entry. Okay, so the other aspect that you should know, I thought you should equally know the last type of a matrix. We are still on types of matrix. This is number 6. So the other type of a matrix here that you should know, it is an interesting one. This is called a unit matrix. What is a unit matrix? By a unit matrix, it is also called an identity matrix. Identity matrix. This is similar to a diagonal matrix. However, this one, all entries are 0 except the diagonal, which has entries equals to 1. So let's say we have 1, 0, 0, 1. This is a unit matrix. Why? It is 1, 1. Equally, you can have 1, 0, 0, 0, 1, 0, 0, 0, 1, like that. So equally, even this one, it is also called a unity matrix or an identity matrix. This is about introduction to matrices. Just a simple exercise that we should do together. I want you to identify this for me. What is this? What do we call this now? If I have this, what type of a matrix is this? Come on, come on. What type of a matrix? Is it a row matrix? Or is it a column matrix? Or is it an identity matrix? Remember what we discussed? Exactly. This is a column matrix. So it's a column matrix because we just have one column. Okay? Let's try to do this. Let's try to do this. What about 1, 4, 7, 2? What is this called? What type of a matrix is this? Thank you so much. It is called a square matrix. Oh, brilliant. Why? The number of rows and the number of columns, they are the same. Good. What about this one now? Zero matrix. Thank you so much. This is called a zero matrix. All entries are zeros. Okay. Okay. What about this one now? Correct. This is a square matrix. Why? It's because the number of rows and columns are equal. This is not an identity. It could have been an identity if 1 was here, 0 was here, so that we have got the diagonal. Yes. Okay. The last one, let's do the last one together. I hope this will fit here. Let me just do this. I come here. So the fifth one here, let's look at something that is in the form of 7, -8, 0, 0, like that. What is this called? Yes, thank you so much. This is a diagonal matrix. Thank you so much. This is a diagonal matrix. This was about our introduction today on matrices. Check out on lesson on part 2 on matrices. Thanks so much for your time. Have a blessed day.